Hi folks, welcome back for part 2 of our introduction to Surds for year 10. In part 1 we had a very quick look, a very quick refresher with a simple straightforward example of Pythagoras' theorem. This video is going to look at just another way, if you like, of looking at Surds. It might have come up at some point in your in the past years as just a random question. So not an entire topic. But I want to talk about the idea of squares. Okay, if I've got a square and I tell you that the side length of the square is 4 units, okay, so that means every side is 4 units, all the sides are 90 degrees. What's the area of the square? Okay, well, the area of the square is the side length squared, 4 squared is 16. Okay, that's pretty straightforward. What about if I reverse this a little bit? What if I said, look, here's another square. Okay, all right angles, all sides equal. And I told you the area of this square was 9. The area is 9. Well, what's the side length? How long are the sides? If the area is 9 square units, then what is the side length of that square? Well, you need to come up with a number where if you multiply it by itself, you'll get 9. Obviously the answer here is pretty straightforward, it's 3. Okay? 3 times 3 is 9. Okay, Mr. Obeid, you're giving us these really straightforward examples of these nice whole numbers that work out to easy things that we can work out. We'll stretch it a little bit. What if I told you, well, here's another square. What about if we had a square whose area was 2? Okay, all the angles are 90 degrees, all the sides are equal, and the area of this square is 2. What's the side length? What's the side length? What two numbers multiply to give me 2? Well, it's certainly not a whole number. You know, 1 times 1 doesn't equal 2, 2 times 2 doesn't equal 2, and anything bigger than 2 is going to be bigger than 2. So we're after a number that's sort of between 1 and 2. But what is that number? Well, it's a new kind of number that we haven't seen before. It's what's called an irrational number. It can't be written as a fraction. Okay, and now we've never seen a number that can't be written as a fraction before. Okay, well, that's not true. We have, but we haven't studied them in any sort of detail. There's a very famous number that's irrational that can't be written as a fraction. And we've seen that when we do areas and circumferences of circles. That's the number pi. Right? We can have guesses about what pi is. It's kind of close to 22/7, or, you know. So there are fractions that come close to what pi is, but there's no fraction that's exactly equal to the number pi. And it's the same with the square root of 2. There's no fraction that is exactly equal to the square root of 2. There's no fraction where if we multiply that number by itself 2 times, we'll get exactly 2. So the way we write the side length here is we say we're after the square root of 2, and we can't simplify that any further. Okay, so if we think about the idea of a square, we start with the area, and then we realise that the side length has to be a number that you multiply by itself to get that area. Well, then if we think about an area of a square with an area of 2, well, its side length is a new kind of number. Okay, we call these things surds. Surds are irrational. So strictly speaking, if I talk about, say, for example, the square root of 9, well, the square root of 9, strictly speaking, is not a surd, because I can simplify the square root of 9 to get an exact value. Okay, square root of 9 simplifies, it's exactly 3. I can simplify other numbers, and you can try these on your calculator. So if you get your calculator and say, you know, what is the square root, for example, of 2 1/4? your calculator is going to tell you that that's going to be a 3 over 2 or 1.5. Okay, we'll see why that is later on, right? But so that there is, strictly speaking, the square root of 2 1/4 is not a surd because it's got an exact answer. The square root of 9 is not a surd, it has an exact answer. The square root of 2 is a surd because there is no exact number that is the square root of 2. Okay, so that's our first real look at an irrational number. So we say this is irrational. Can't be written as a fraction. So see the word ratio in here. Well, the word ratio means to express one thing in terms of another. In other words, a fraction. Okay, something that is irrational means it's not fractionable, if you like. You can't write it as a fraction. So here's our very, very first look at irrational numbers, our very first look at actual real surds. Next up, we're going to learn a couple of important rules.